Hello, Algebra 1. Here is the video that's going to go over example problems 2 and 6, as well as practice problems 2 and 6. These will be identical to your homework problems number 2 and 6. So, I apologize for the awkwardness in class with them, but here we've got them straight and we're going to go through it fairly quickly. Hope you are having a good afternoon. Let's start. Bowl-O-Rama charges $2.50 per game. Well, 250 is your coefficient. Game tells you that we're going to use a variable g. Plus tells you we're going to add something together. $2 for shoe rental. Now remember, this was a unique one where we said this was a constant. So we were going to put a box around things that were constant. All right, so we are going to continue reading. Bowling pins charges $2 per game. That's our coefficient, so we underline it. G is still our variable for game. Plus $4 for shoe rental. So there's another constant. Question asks, how many games will the cost to bowl be the same at both places? And what is that cost? So here's that second variable that we've had in other problems. Cost. We're going to make C equal cost. So now let's try to put this into equations. First, let's do the Bowl-O-Rama equation. Bowl-O-Rama, its cost for anything equals $2.50 times G plus $2. That's how you're going to calculate the cost. Bowling pins equation then is cost equals $2 per game plus $4. Now, because we see that this expression is equal to C and this expression is equal to C, since they're equal to the same things, we can say they're equal to each other. So we could rewrite this in order to solve this as 2.50g plus 2 equals 2g plus 4. To solve this, we subtract 2g from both sides, and we get 0.5g plus 2 equals 4. So now we subtract 2 from both sides, and we get 0.5g equals 2. When we divide by 0.5, g is going to equal 4. This means that 4 games will give you equal cost. Now, that's the answer to the first question. The second question is, what is that cost? So what we do is we plug back into either one of our equations, our 4 games, to find out how much that would cost. So let's go with this second equation right here. Cost equals 2 times G, which is 4. We substitute that in for G, plus 4 equals 8 plus 4, or the cost is 12. So you would say that the cost is $12, and you do want to show it as dollars, not just the number. In example 6, we're dealing with a boat traveling downstream. Now, when something travels downstream, it has the speed it's going, plus it's being pushed along by the current. It also is traveling back upstream, and when something travels upstream, it's got its speed of the object, but it's fighting against that current that's going downstream. And so we're going to have to take that into consideration as we do a problem like this. So first, it says, a boat traveled 210 miles downstream and back. Well, this right here is our total, which is why we're going to circle it. It's our total. It's what things are going to equal. In order to get distance, you have to have your speed times your time, and that equals distance. So when we look at the rest of the problem, we're going to want to be trying to identify what is our speed and what is our time, okay? So the trip downstream took 10 hours. 10 hours. That's your time. That's going to end up being a coefficient to our variables. The trip back took 70 hours. Again, that's going to be another time issue. What is the speed of the boat? We're going to let that be variable S. And then the other question is, what is the speed of the current? How much is that current either helping us downstream or fighting us as we come back upstream? Now, how do we write the expression for the speed going downstream? Well, the speed going downstream is going to be the speed of the boat plus the speed of the current, because the current's helping push us along. This is just like in problem 5, where it was speed of the plane plus the wind, right? The trip back upstream then is going to be the speed of the boat minus the speed of the current that's fighting against us. So when we put this into an equation, you're going to have, for the downstream one, 10 hours for your time times the speed, your S plus C, equals your distance, which is 210 miles. Now, for the trip back up, again, you're going to have 70, which is your time, times your speed, which is S minus C. Right there, we talked about it, equals, again, the same distance, 210 miles. So now, when we're trying to calculate this, the first thing we need to do is get it into a simple equation. And when we've got this multiplication here like this, it's not quite as simple. So we're going to need to divide by our coefficients. So we're going to divide by 10 for this equation. And when we do that, this becomes a giant 1, and we get S plus C equals 21. Now over on this other equation, we're going to have to divide by 70. And we get S minus C equals 3. Well, now we have two simple equations that we can put on top of one another so we can do elimination with it. So I'm just going to move this one over here. S plus C equals 21. S minus C equals 3. Let's add them together, and you're going to get 2S equals 24. Divide by 2, and you get that S equals 12. Now, speed is always in the units of miles per hour, or mph. Now we just take that and plug it in. So let's go 12 plus C equals 21. If you subtract 12 from both sides, you get that the speed of the current is equal to 9 miles per hour. Okay, so here is practice problem number 2. This was on the second page of that packet we were using as notes. What I want you to do is I want you to pause this video and I want you to mark up the problem and try to get equations just like you did with the example number 2. Okay, so I've marked up our question for us. $10 is our constant, so we put a square around it. $3 per visit. Remember, when we see per something, we're thinking, oh, that's a coefficient. So 3 is our coefficient. V for visit is our variable. For gym B, 15 is our constant. $2 is our coefficient, and V is our variable. And then we're trying to find cost. So we're going to just let that equal C. So for gym A, our equation would be $10 plus 3 times each visit equals the cost. For gym B, it's going to be $15 plus $2 per each visit equals the cost. Now, we're trying to find out when they will cost the same. Because they're both equal to C, we can just set them equal to one another. So we would have 10 plus 3V equals 15 plus 2V. Now to solve it, subtract 2V from both sides. You get 10 plus V equals 15. Subtract 10 from both sides. You get V equals 5. So at 5 visits, the cost will equal each other. Now, we're also needing to know what the cost is. So you just take this 5 and substitute it anywhere you see the V. So let's do it for the first equation. 10 plus 3 times 5 equals the cost. Well, that would be 10 plus 15 equals the cost, or 25. Our units for this is $25 is the cost. Here's practice problem 6, again from that stapled together packet. I want you to pause this right now, try to mark up the problem like we did on the example number 6, and then we'll come back together. Okay, so this is how you should have it marked up. 336 is our total distance. Now remember, distance equals speed times time. And for this, you have to take into consideration the speed of the boat and the speed of the current. So speed of the boat, as we said down here, is S. Speed of the current is C. As we go downstream, we're moving with the speed of the boat plus the current. The current's helping us. So downstream is S plus C, and our coefficient's going to be 12 hours because that's how long it took us. Coming back up, we are fighting that current, so our speed is going to be subtracted, right? Speed of the boat minus the speed of the current, and 14 is going to be our coefficient because that's how long it took us. So in order to write these equations, you would write 12 times S plus C equals our distance, which is 336 miles. Going back up, it would be 14 times S minus C equals 336 miles. Now, just like before, we want to get this into a simple equation for us to use elimination with. So we're going to divide this first one by its coefficient, and we would get S plus C equals 28. The second one, we've got to divide by 14. And we would get S minus C equals 24. So now we want to put them together in such a way that we can do elimination. So we would want to put S minus C equals 24 right under this equation. Add them together. And we get 2S equals 52. If we divide by 2, we find out that S equals 26. So the speed of the boat equals 26 miles per hour. Now, in order to find out what the speed of the current is, we've got to plug this back in to one of our equations, and I'm going to choose to put it into the first one. So we get 26 plus the speed of the current equals 28. You subtract 26 from both sides. You get that the speed of the current is 2. So speed of current equals 2 miles per hour. All right, I hope that helped clear up those two difficult problems from today's class. I hope you guys have a wonderful 4-day weekend and a great week in between when I saw you today and when I see you next. Bye.